Hello, Algebra. In this one, we're going to be working on distances in the number line with fractions. Here we go. In number one, we are thinking of fractions with area. So if a filled in square like this has an area of 1, what is the area of each of these shaded sections? So this first one, this area would be 1/4 because 1/4 of the square is shaded. In the next one, I see that I have half of the 1/4 shaded, which would be 1/8. And if I counted up, there would be 8 triangles here, and one of them is shaded. In this next one, we have this little tiny rectangle that's shaded. If I count up, there are 8 rectangles here, and one of them is shaded. So this would have an area of 1/8 as well. In this next one, I can see that I have 4 of these triangles shaded. Now I'm visualizing it as I could put together 2 of these triangles to make one square, and I could put together 2 of these triangles to make one whole square. So I would have this much shaded, which is going to be 1/2 of the total area. In the next one, we have 4 of our little rectangle shaded. Now we already saw that one rectangle was 1/8, and so now I have 4/8 shaded, which I could simplify to 1/2. In the next one, I see that I have 4 of these little rectangles shaded, and I already knew that one little rectangle was 1/8, so if 4/8 of them are shaded, that would be the same as 1/2. In number 2, this is going to be similar to what we did with decimals. If we have a target number 5 3/4, we're first figuring out which integers or whole numbers it's between. So it's between 5 and 6. And then we're finding the distances. So between 5 3/4 and 6 is a distance of 1/4. And between 5 3/4 and 5 is a distance of 3/4. In number 3, -4 2/3 is between -5 and -4. My distances here between -4 and -4 2/3, that would be 2/3, and between -4 and 2/3 and -5 would be a distance of 1/3. And let's skip to number 5. If our target is -6 and 3/8, that's going to be between -7 and -6. -6 and 3/8 is going to be not quite half, so it's going to be right about there. And I know it's not quite half because 4/8 would be half. And now I'm looking at my distances. This distance would be 3/8, and this distance would be 5/8. Notice that my distances, when I add them together, they always equal 1 because it's always a total distance of 1 between my integers. Number 6, now we're looking at a number 6 3/8, and how far is it away from 7? So this distance here would be 5/8. And I'm knowing that because from 6 3/8 to 6 is 3/8. And so to add to 1 between those two integers, I need that distance there to be 5/8. The distance from 6 3/8 to 10, well, I'm going to break that up. I know that this distance to 7 is 5/8, and then 7 to 10 is 3. So between the two of them, it would be 3 and 5/8. From 20, I'm going to look at the distance from 7 to 20, which would be 13. So I'd have 13 and 5/8. And from 6 3/8 to 100, well, I have my 5/8 here again to get to 7. 7 to 100 would be 93. So I'd have 93 and 5/8. Down to number 7, how far is -9 2/3 from 0? Well, that's 9 2/3. How far is -9 2/3 from -10? I'll put that right here. Well, that's just going to be 1/3. How far is it from -30? I'll put -30 right here. From -10 to -30 is 20. And then I had the 1/3 right here, so this would be a total of 20 and 1/3. And then from +10, we'll put +10 on the other side here. And I'm going to go from 9 2/3 to 0, that's 9 2/3. From 0 to 10 is 10. Put those together, it would be 19 2/3. In number 9, my distance from 7 1/3 to 8 is going to be 2/3. From 8 to 12 is 4, so my total distance is 4 2/3. In number 10, the distance between -2 and 5 and 3/8. I'm going to add 5 right here as an easy one. From -2 to 5 is going to be a distance of 7. And then from 5 to 5 and 3/8 would be 3/8. So my total distance is 7 and 3/8. In number 11, I'm going to put -2 right here. This distance is going to be 1/4. From -2 to 1 is 3. So my total distance here is 3 and 1/4. Let's skip to number 14. The distance is here. Let's put in our integers that will make it easy. 6 will go here, 10 will go here. So the distance between 6 and 10 is going to be 4. From 6 to 5 and 3/5 is going to be 2/5. And from 10 to 10 and 1/5 is going to be 1/5. So if I add all these together, I'll have 4 and 3/5. One tricky part on this one would be that I figured out that the heart was 2 over here. And so here I have 2 hearts, so that's a total of 4. So to have this entire side be 6, that means each side down here needs to be 1. Because this would be 1, 1, and 4, that's 6. And that's how I got the triangles to be 1/2 each. In number 17, 0 plus 10 is going to be 10. And now I'm looking at 1 and 3/4 plus what gets me, I know it needs to be 10. So I'm going to think of something a little bit easier. I'm going to put in 2 here because that's really close to 1 and 3/4. Now 2 plus what gets me 10, that's going to be 8. So that's going to be right here. Now the distance from 1 and 3/4 to 2 is going to be 1/4. So this distance over here needs to also be 1/4, except this side is going to be larger. So that would be 8 and 1/4. So it's 1 and 3/4 plus 8 and 1/4 is what gets you 10. I'm looking for sums that equal 10. My whole number parts need to add up to 9 so that my fraction parts can add the 1 more to get me to 10. And so this first one, this one works, and this one works. This one over here does not, because 9 plus 1 is already 10. If you add on another 1 with the 1/2 plus 1/2, that would be 11. In the second row, 7 plus 2 is 9, but 1/3 plus 1/3 is not 1. That would be 2/3. That's not going to get me 10. Next one, 8 plus 2 is already 10, so those fractions are going to make it more than 10. Same thing here, 6 plus 4 is already 10, so the fractions make it more than 10. In the next row, that one works, and this one works because 6 plus 3 is 9, and the fractions add up to 1, and this one works as well because if I add 2/3 to 9 and 1/3, that is going to get me 10.